Now, when we begin to look at the circulation, in our systemic circulation, meaning the blood flow to all the tissues of the body, a lot of factors play into this. We have to think about the anatomy of our circulatory system. We have to think about factors that affect the blood flow. We have to think about regulatory mechanisms such as the nervous system and stuff that might control the heart or the blood vessels. We have to think about the blood volume, and this will all play a part on how the blood is going to move through the blood vessels in the system of our bodies. Now, in the systemic circulation, the overall goal is to keep a good blood supply to all the tissues of the body. The systemic circuit is going to be containing the majority of the blood, where we have quite a bit of it in the blood. And as we think about the blood supply, you know, as we go from large to small and then back from small to large, because the veins have that ability to be a blood reservoir, but the arteries don't, we can see more blood volume in the veins than we do the arteries, because the arteries need to be or react to the pressure being forced upon them. So if we think about how we are looking at the blood found throughout the body, what we're seeing is, in the grand scheme of things, the aorta, we only have one of them, okay? And that's really, really huge. And the blood, okay, is going to move under great pressure. We're going to have a lot of velocity. But as we go from large down to small, okay, there's actually going to be a lot of blood located in these capillary beds because there are so many of them. And then as we begin to return to the heart, once again, we only have, you know, the two big vena cava returning to the right atria. So blood flow is actually pretty good in the aorta, but the actual cross section of it is very small. But we have a whole bunch of the capillaries that are not large, but they allow for a huge amount of blood flow. So it's almost like the water flowing throughout, as they represent here, throughout a stream, where when you have the stream flowing, that narrow point, the gorge, okay, it flows really, really quickly. Think about the aorta. But then when it begins to level out, the flow slows down, but we've got more of the flow. Our blood, when it gets ejected from the heart, is under some really huge pressure. And the heart, because it does that beat, relax, beat, relax, beat, relax, contract, relax, okay? The action of this pumping that's taking place, it's actually termed pulsatile. Think about how you're able to feel the pulse. And it's going to fluctuate between that systolic and diastolic number. And when we begin to look at the pressures, note pressure is very high in the aorta, but look how the pressure drops to the point that when we get into the arteries meeting the veins, the pressure should be almost zero. Now, does that mean that the pressure is going to always be close to zero in these small capillary beds? No. That pressure can actually go up based on the activity that's being done by the body. So at the bigger end of the arteries, pressure is high. At the smaller, pressure is low. And then in the veins, the pressure is going to be close to zero in those veins. We can check the pulse, and there are quite a few areas throughout the body that we can check the pulse of the heart. And usually, depending upon the area that you're checking, there is a norm of what the heartbeat should be. And as we begin to look at the areas that we can check for the pulse pressure, okay, we're using that because, once again, it's clinically significant. And we're doing it to try to determine what is the heart rate and how rhythmic is the heart rate. The body is going to have the ability to control the blood flow in the tissues. And the blood flow to the tissues is going to be determined by the metabolic needs of those tissues. So the way that we control the blood flow, we can have what's called local control, control by the nervous system, and control by the hormones. Well, local simply means that. What is the need of those tissues at this point in time? The nervous system plays a little bit larger role because that's going to help with routing the blood flow as well as helping with the blood pressure. Now, the hormonal control, if we think about sympathetic, think about the sympathetic system and that epinephrine and norepinephrine that get released. Now, as a whole, the blood flow throughout the body is going to vary greatly. What we do know is that in the brain, the kidneys, and the liver, the blood flow is very high, meaning basically 24/7, there's a very high blood flow to the brain, the kidneys, and the liver. The skeletal muscles will vary because it will be dependent upon is that muscle being used or not. So if we look at the local control, basically what is taking place in that area of tissues at that moment in time, it is proportional to the metabolic needs. If that tissue is active, we need more blood flow. In that case, those sphincters that are found in that capillary bed, those sphincters will release and blood flow can increase to those tissues. If those tissues are not at metabolic need, the sphincters can tighten and the blood flow will bypass that capillary bed. In some cases, there are substances that will increase the blood flow in this local area. For example, if that tissue is active, that means it's carrying out aerobic respiration. And if that's the case, well, it doesn't necessarily have to be aerobic, but if it's carrying out respiration, it's going to generate waste. If we think about CO2 that gets produced as being a waste, we need to get rid of that. A metabolic need is open up this sphincter, let the blood flow in, pick up that CO2, and get it moved. So those sphincters are very important. They are smooth muscle. We are not controlling this. This is done strictly by the tissues, the cells that are located at these capillary beds. If we think about the blood flow to the tissues, the blood flow can increase significantly. And the reason for that is that area of the body could become active. So we can have it increase significantly. And one of the things that will happen is we have at this local level, at this tissue level, auto-regulation, meaning those tissues regulate that blood flow. We do find that with those precapillary sphincters that we will have periodic contraction and relaxation if the tissues or the muscles, whatever the case might be, if they're not in use. And that's just okay, let's drop a little bit off, pick a little bit up, go back, open them, close them, open them, close them, helping to keep the tissues alive. Now, the nervous system, with the nervous system, this is very important for minute-to-minute regulation. Basically, being monitored 24/7, 365, 366 if it's a leap year. This means that if we, say, for example, begin to exercise, okay, at that point, the nervous system is picking that up because it's a stressor on the body. Therefore, it's going to open up or dilate those sphincter muscles, and the blood flow will increase. Another thing that begins to become important from the nervous system, because the nervous system has the control over these sphincters, it can actually help shunt blood, meaning we can have blood moved from one area of the body to another. And this becomes important in times like if there's a blood loss or something that could happen in case of an accident. And the way that the control is taking place is the nervous system, by way of that vasomotor center, okay, it's monitoring all of that information, and it will actually begin to affect that movement or that flow of the blood through this vessel system that we have. If the blood flow is too low, one of the things that'll happen to the body, it'll go into circulatory shock, and that could definitely lead to death. If the pressure goes too high, we can actually damage our heart and the vessels. And therefore, our blood pressure, which is a clinical indicator of this pressure, of the rhythm, of the pulse, the movement, the flow of this blood, the blood pressure is influenced by three factors. It's going to be influenced by our heart rate, our stroke volume, and then peripheral resistance. Now, your book is going to get very detailed about this. What I want you to understand, an increase in any of these factors, okay? If we increase any of these, then we're going to affect the blood pressure, and the blood pressure will elevate. If that blood pressure drops too quickly, these factors are going to be affected. So it's important that we have the blood flow managed by those other systems, those other controls, I should say, that are in place.